So in this video I'm going to discuss code force around 946 rated for division 3. So I will be solving first 5 problems in this problem set. So let's start with problem A. This problem very much pretty much easy problem. So I will be not telling you the solution of this. I will provide the solution in the comment section. So let's now start with B problem, that is symmetric encoding. So in this question you are given a original string S, that is code forces. You have to perform a operation on this string. Simply first of all take all the distinct characters from the string and sort them in increasing order. Okay, that's it. The final string would like this. Now you have to map the numbers, map the characters. But how? You will map the first character with the last character, second character with the second last character. Okay, so that's how you have to map the characters. Okay, so after mapping the character, you have to replace the each and every character with this map character. For example, if there's a position where C is occurring, you have to replace C with S, and if there is a position where S is occurring, you have to replace S with C. So how you can solve the problem? Just you will be given the encoded string. You have to decode it into original string. So how you can solve the problem? Simply follow the same steps, and you will get the original string. So that is what question asking you to do simply. I will provide the code in description also. So let's now begin the problem number C. That is beautiful triplet pair. So this question was very much interesting. So let me tell you why. So for example, you are given a string like this. You are given an array like this. A, B, C, D. Let me copy it only. Okay. So for example, this is the original string which is having with you. Okay, great. But what to do next? In this question, you have to tell them how many indexes are there. So for example, you choose to any two indexes. I am choosing like this index, and I am choosing like mm, I think so. It is not favorable to me. So 2323, yes. So for example, I'm choosing this index and I am choosing this index. Okay. So this how I have to tell them whether this pair is valid or not. But how a pair become valid? So to make a pair valid, you will pick up the all the three numbers which are occurring in this pair, including this. So this is 1 2 3. Okay, 1 2 3, and pair of this would become 2 2 3. Okay, this will become 2 2 3. Okay, now now a pair is only valid if there is only one index in this pair such that that is not matching and other two are matching. Okay, so in this you can see my next two pairs are matching, that is 2 3 and 2 3, but my current index is not matching, that is 1 and 2. Okay, so this become now a valid pair. But in this question you have to find a total number of valid pairs which are there, and costs are very much high. You cannot brute force it all. So how to solve this problem? So I will tell you the approach to how to approach this problem. So for each and every index, create a map. Okay, so for each and every index, create a map. For example, for this index, I will create a map like this. So first index would be blank. Okay, now second would be 2 and another would be 3. Okay, I will tell you the meaning of this later. Okay, now map for this. Now map for this can be like dot here and 3 comma 2 here. Okay, this is a valid pair also. So let me tell you the intuition of this part. So for each and every index, for each and every index, I will try to generate like my this current index would be different and my rest two numbers would be same. Okay, I will try to find that pairs. So if my this number is same, my other if my this number is would be different, I will try to find pairs among these. So okay, so for these two three pair, what is the number coming from me? That is one. Okay, and how is this pair coming from two? Okay, there's another pair from which from there's another one more pair from 2 which is occurring. What is that? That is 1 and dot in the center and 3 here, because that is also a valid pair. Okay, now this is again coming from 2. Now for 3, what are the valid pair for 3? The valid pair of 3 are 2 dot 2, that is 2 and here. Okay, and where is this coming from? This is coming from 3. Okay, now what are the other valid pair for 3? That is dot and again 2 and 2. Now you can see if there is 2 and 2 coming before, no, so you will create a new entry here. Okay, now this is coming from 3. Okay, great. Now there is one more pair like 1 2 and dot here, because 3 can occur here also, so that is 3 here. Now for this 2 index, how many valid pairs are there? Okay, so like in the center it will be 2 and 3 comma 2 here. Okay, great. Now 2 comma 3 in the next. Now you can see 2 comma 3 is already been occurred, so you will simply add 2 here because this is the same pair at which my 2 comma 3 is coming. Okay, and another pair would be 2 comma 3 in the back. Is there any 2 comma 3 in the back? No. So you will simply add another more pair, that is 2 comma 3 and dot here, and simply from where this index is coming, this index is coming from 2 and 2. So similarly, you will create a pair for each and every index. But what to do next? Okay, now let me take an example. For example, you are having an index like this. For example, dot here, and let me change the color, and 1 comma 2 here. Okay, now you will check how many positions are there, how many different dots, how many different possible numbers are coming in the place of dot. That can be like, for example, 1, 2, 3. It can be like, I can take another number, 4, 6, 7, and multiple sevens can also come. So for example, in the hypothetical array, these much these are the numbers which are forming a pair like this, which means the pair can be formed like 1, 1, 2, and 3, 1, 2, and 4, 1, 2, and similarly 6, 1, 2, and similarly 7, 1, 2. Okay, so these are the pair which will be forming using these two arrays. But what to do next? How you can calculate the answer? Now calculating the answer is very much easy. Now you know that for each and every index, now for each and every index, you have another another this much different entries for this single pair. So simply multiply that part. Simply multiply the occurrence of current number into the number of leftover parts. So what are the number of leftover parts? That is 1, 2, 3, 4, 5, 6. That is 6 plus for this 3 also I have to add 6 again. Okay, for this 4 I will have to 6 again, and for this 6 I have to add 6 again. But for this 7, how many different pairs are left? Only 4 different pairs are left. And how many occurrences of 7 are there? Total 3 occurrences of 7 are there. So simply multiply 3 into 4. So that much number of pairs would be coming from this pattern, that is dot 1 2. So for each and every pattern, try to find the answer using this equation. So that's how you can solve the problem number B. So problem number C. Okay. So you will get the code in the comment section. So now let's discuss the problem number D, that is integrity 2. So that is a very much interesting problem. I think so. I like this problem very much. But why? Let me tell you. Okay. So this is a problem. So in this problem, I hope so you have understood the problem. I'm just telling you the solution. So in this question, you are given a direction like this. Okay, I'm again telling the question. No worries. Like you are given a direction like this. Okay, you are currently on 0 0 point, and you have two you have two persons, like it will be R and let it be H. Okay, you have to guide these two person according to this equation. Like first person can go to north, then you would say that second person you go to east. Okay, now again say first person you again go to south. Okay, this is the south. Now you say like second person go to south. Okay, now he go to south. Now you say that second person go to west. Now he go to west. And then you say that first person go to south. Okay, now go to south. Now you notice one thing. And then my both of the players are coming at the same position. Okay, now this is the first question asking you to do. Simply tell whether you can reach at the same position or not. Or if you can reach the same position, tell me the guidance also. Like for that north, this operation was given to R. This is east. This operation was given to H. Okay, you have to tell it also. So how you can solve this problem? So I will tell you the intuition of this problem. And the code which I wrote in the contest was, I think so, more than 100 lines. So you can understand that also, but there must be a simpler implementation. So I will tell you the intuition part. Okay. So first of all, try to eliminate the redundant steps. Okay. What do you mean by redundant steps? Okay. So in the end, what is your goal? In the end, your goal is to meet at the same position. Let's suppose I'm taking for example, this is 0 comma 0, and your goal is to meet at this position. Okay, your goal is to meet at this position. So let me now make a grid, something like this. Okay, so this is a hypothetical grid. Okay, so your goal is to, you are starting with this index and your goal is to meet at this index. I'm just taking goal from now because you cannot set goal in the previous section. Just I'm taking hypothetically, you have set in the goal that you will meet at this position. But you know one thing, like the number of north and south each person would travel would be same. But how? I will tell you. For example, this person now tries to travel. Let's suppose this person go to north in this direction and go to north in this direction, then come go to south, then go to west, then go to south, and go to then come to east in this part. Again, let's suppose this person go to this area, then go to this area. This is the second person. Let me change the color. For example, now this person go to this in this area, and now go to this, now again travel to the north. Okay, now again travel to the south, and then come to this position. Okay, now this is the trail of this man. Now you notice one thing, like the number of north and south is same in both the cases. But how? Let's suppose this person, how much north this person go. Let is 1, 2, 3, and 4. So this is 4 north. And how many south does it go? The south is 2 points. I will minus 2, that is minus 2 for the south. And again, that is, and then he is increased, his total value is increased by 2. Okay, now for the second person, how many south did he go? He first of all, he goes out to the 2 position. So that is minus 2. Then he again go now north in which, now he again go to north in how many direction? That is 1, 2, 3, 4, 5, 6, 7, and 8, and plus 8 for the north. Okay, great. Now he again go to south, but in how many times? That is 1, 2, 3, 4, 5, 6. That is minus 6. Now what is the total? uh, I think so he stopped here only. It is not minus 6. It would be minus 1, 2, 3, 4. Okay, it would be minus 4. So what is the total threshold in the vertical direction? So total threshold in the vertical direction is 2 only. That is same for the both the persons. Right? I'm right. Yes. Now what is the total distance traveled in the horizontal direction? That is 1, 2, 3, and 4. Okay, plus 4. And how many in the west direction? That is minus 2. Okay, that is again equal to 2. Now for the another person, what is his threshold? That is same, plus 4 and minus 2. Because plus 4 is going, because where is plus 4 coming from? Plus 4 is coming from this direction and minus 2 coming from this direction. So add then it is also 2. Now you notice one thing, the number of north and south, the sum of north and south add then would be equal for the both the persons. Now this also rises to the one more case. Like you can cut down the redundant steps. Again, I'm using this same equation, redundant steps. But what does the redundant steps means? Here you notice one thing: the north and south are been cancelled by each other. For example, this is the north and south. If there are four north and there are two south, then at the end my two north are already been cut by my two south, and at the much I'm remaining. For example, this my positive is north and my negative is south. So this is my north, this is my south, and at then I'm remaining with only positive. My positive represent north. So this is two of north. So which means north and south will cancel out each other. North and south will cancel out each other, and at then I have remained with two norths. So that is what my two n denotes. Okay. So hope so you understood this much. But what to do next? Simply remove the parts. This is north, this is south, cut it. This is east, this is west, cut out. Now you are at then left with only two souths. But how you can deal with these leftover parts? The leftover part is also easy. If there are two souths, simply make one to south and another to south. For example, this is 0, 0 point. Simply first move R to north, R to south, then move S to south. So that's how you can solve the problem. So let me debug another more test case. This is a very much good test case, I could say. Okay, so now what next? So how I am cutting in now? So this north will be cut by south. Okay, this east would be, though this east would I cannot cut because there is no more west. Can this north be cut in? No, this north cannot be cut because there is no more south. So now you, but then at then but you are left with the operation. You are not left with east, north, and north and east. So the answer is simple. First of all, move one person to east and then south. And in this, first of all, move another person to first of all north and then south, then east. So there is also one more condition to check in the end. Okay. But what is that condition? For example, that you are having like north, east, north, south. This, for example, I'm taking the same test case, that is south, and for example this is east. Okay, so you have cut in the north, you will cut here, you will cut north with south. Okay, but they are no more cutting. So what is the finest thing? That is east, north and east. Okay, yes, but notice one thing, that my number of each and a number of norths and north are not total odd, are not total even, because if the total number of even steps left, then that's why, then in that case you can divide the operation in the equal parts. Because if you can see, can you divide it in the equal parts? No, I cannot divide. So in this case answer is no, which means if after cutting down the each and every step, or I could also denote it like, if your length of string is odd, then answer is no. Okay, if your length string is odd, then answer is no. But if your length of string is even, then what to do? Simply cut down the north and south, east and west, north and south in each in east and west, and add, then check whether you can, and rest is simply printing the answer. But how you can print the answer? Simply equally divide the operation. Like if they're two east, simply make one to east and second to east. If they're two north, simply make one to north and another to north. For example, I have viewed the operation like this is R and this is R, and this operation will be performed by H, and this operation will be performed by H. So that's how you solve the problem. So you will get the code in the comment section, but my code is very much lengthy, because I think so I didn't solve this very much. So this is the number of lines of code which I wrote for this problem. You can understand this code also, but this is very much easy, or you can get the better code in the editorial part also. But if I repeat the main intuition, the main intuition is simply like that. Simply cut the north, east, simply cut north with south and east with west, and add, then check, and add, then try to make try to divide the operation equally. For example, after cutting down the equation, let's suppose you are left with north, north, and east, or you will left with north, or west. So simply give. Okay, so simply, so I think so you cannot divide in this case. This is north and it is east. So what you will do? Simply make two operation with R of north, two operation of E with R. Okay, and make rest of the operation with H. In this case, make this with R, make this with H, and make this with R, and make this with H. And I forgot to tell you one more thing. That you are cutting down some operation, which means your N, E, N, S, and E would become, after cutting down the north and south, would be something like E, N, N, and E. Okay, but what to do on N and S part? Simply print any number, any string. Let it be R or let it be H, because at then its final effect is nullified. So either you write R or either you H. It doesn't matter. So you can find the answer. So let me now discuss the last problem. That is problem number 3. So this is a DP problem, so I think so I cannot explain that DP problem on this whiteboard part. So I will show you the code and try to tell you the code itself. Okay, so this is the code. So simply, first of all, what I will do, I will simply first of all taking the input. Okay, now what will be my DP states? I will make a 2D DP. My first of the number represent the number of month which have been passed down, and my second number represents the number of salary, total sum of salary. Okay, now now what you will represent, that first of all take the sum of the happiness which you have get. Okay, first of all find the sum of the happiness, total happiness. Now again what you will do, simply assign my 0 with, so you know one thing like that, if your happiness is 0, if your happiness is 0, right, then then in any month, you cannot spend any much amount. Yes, this is the truth. Yes, you cannot spend any of the amount if your happiness is 0. Yes, I am right. And also one thing, if none of your month has passed, please listen this carefully. If your none of the months has passed, you cannot be happy. So simply assign with a very big number. Okay, great. Now what you will do next, you will start you will this is only the DB function. So you will iterate in the you will iterate from 1 to n. This represents the number of months which have been passed down, and this represents the current happiness level. Okay, now you know one thing. If your if your current happiness level, like this is the definition, if your current happiness level, that is C of, if your cost of I, let's suppose this is the cost of I, if your cost of I plus the number of costs you've spent in the previous number, I will repeat, your current cost plus the total number of costs which you have spent in the previous month is smaller than the number of saving which you have, then you can definitely, then you can definitely take the current happiness. Okay, then you can definitely take the current happiness, and your answer dp of I and j would be the minimum of previous value comma, if you can take the current value including the previous value and it is also greater than that number, then simply store the minimum of both the numbers and try to find the answer, and the maximum number and the maximum sum where you were able to find the better cost, that would be your answer. So I think so it is clear to you, but you have to debug it in your end only, because this is a DP problem. This cannot be, I think so, understood on a whiteboard. So I will provide the link, code in the comment section. And if you have any doubts in any of these five problems, except the C, except this DP problem, because I think so I cannot make it clear more properly. So you can please pin me and stay tuned for the next one. Thank you.